Good morning. I'm Durga Prasad from Guru Nanak Dev Engineering College, Bidar, Department of Electrical and Electronics Engineering. Today, I'm going to discuss the construction of a DC machine. Let us see the basic parts of DC motor. We know that the basic parts of a machine are stator, rotor, yoke, poles, field windings, armature, commutator, brushes. These are the main parts of a DC machine. Now, if you see that yoke, it's generally yoke is a strong material. It will protect the inner parts. That's why it is made up of cast iron or steel. And inside on the stator poles are there. Poles are even numbers, and these are joined to the yoke. And on the poles we have the field windings. Generally, these are made up of copper. And next we have the armature. Armature is a thin laminated circular discs, and all these discs are stamped together because it will reduce the eddy current losses. That's why I use laminated disc. And next, commutator. So commutator is a it will connected to the armature. Armature coils are connected to the commutator segments, and these are insulated from each other. And next, brushes. Brushes are made up of carbon and graphite. Brushes collect the current in case of a DC generator, whereas in case of motor, it will supply the current to the armature. Now let us see the figure. So this is the basic construction of a DC machine. Now the outer frame is called a yoke. It, and then the inner periphery. In the inner periphery, we have the stator, and on that we have the stator poles, north, south, like alternate poles we have. And on the poles, it's a pole shoe. It's called pole shoe. And the poles, we have the winding. That winding we call as a field winding. And inside we have the armature. This is the armature, and it has armature slots. These are the armature slots. In the armature slots, we place a winding. That winding we call as a armature winding. And it is connected to the commutator, and these are the commutator segments. These commutator segments are equal to the number of armature coils. And these are the brushes. These brushes lying on the commutator. It will contact with the commutator. Now in our laboratory, we have the cut sections of DC machine. So this is the cut section of DC machine. This one we will demonstrate to our students. So this is a yoke. So the outer periphery, the outside part is a yoke, and these are the field poles. This is the field pole. On the field pole, we have the field pole winding. This is the winding of field pole. And next inside we have the armature. This is the armature. So if you see that armature has a circular discs are stamping together. So if you see that one, it has a pieces, all pieces stamped together. So this and armature slots. In the armature slots, we are placing the armature winding, and this winding further connected to the commutator. This is the commutator. So these commutator segments, these commutator segments are equal to your armature coils. Each coil is connected to each segment, and on this commutator, the brushes are lying. So brushes are physically contact to the commutator, so that current collected from the brushes in case of a DC generator, whereas in case of motor, the current will supply the current from brushes. Through the brushes, we will send the current to the armature. And this is a terminal box. The terminals are taken out from here, and this is the base. And here we have the fan. So this fan to cool down the armature. When the current passes through this one, it gets heated, the winding gets heated. So to cool that one, we have a fan connection. So it cools the inside part. And this shaft, this all fan, armature, commutator, all are connected to this shaft or are connected to this shaft. So these are the basic construction of a DC machine. So next class, we will see the working principle and different types of DC machines. Thank you.